This lesson is going to talk about prime numbers. Prime numbers are numbers that can only be divided or factorized by 1 and themselves only. Examples of prime numbers, we start with the number 1, because 1 can be divided only by 1 in itself. When I say divided, I mean it doesn't leave any remainders. The next prime number would be 2. The next prime number would be 3, 5, 7, and so on. All right? 11. It goes on to infinity. One application of prime numbers is coding. It is something that we are all using today. It is the way that the internet maintains its security. It is the way that companies maintain their security. It's the reason why we have passwords to our emails, to our accounts, to our everything. They use big, very big prime numbers to code and decode information to allow us to keep our personal information secret and safe. In addition to prime numbers, I'm also going to talk about multiples. As the word suggests, multiples are a multiple, or if we start off with a number, let's say the number 5, multiples of 5 are 5 multiplied by 1, multiplied by 2, multiplied by 3, and so on. These are multiples. So 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and so on. Of course, 0 is also a multiple because it's 5 times 0. We cannot forget the 0. Another item that we should also talk about is factors, because we will get to factors. Factors are the numbers that divide a certain number. So as I said, a prime number is divided only by 1 in itself. So a prime number has only 2 possible factors, 1 and the number itself. In the case of 1, it's just the same. But that's a unique case. That's why we just tend to skip 1 as much as possible. However, for example, if I have 30, 30 can be divided by, the biggest number that 30 can be divided is itself, 30, of course. It's 30 times 1 that gives me 30. And then I have 15, because it's 15 times 2 that gives me 30. Then I have 10. It's 10 times 3 that gives me 30. Then I have 6. It's 6 times 5. And these are the only factors of 30. If you notice, usually we have an even number of factors. Here's a point. If we have an odd number of factors, then that number is a perfect square. That's something to keep in mind. Even number of factors is just a regular number. Odd number of factors is a perfect square. For example, 25 is a perfect square, as we know it's 5 squared. 25, it's 25 times 1, and 5 times 5, basically. As you notice, 1, 2, 3, odd number of factors. Here in 30, it's 1, 2, 3, 4, 5, 6, 7, 8, even number of factors. Now, I'm going to move back to prime numbers, and I'm going to link it back to prime factor decomposition. Prime factor decomposition is when we are breaking down any number into prime factors. What we tend to do is we tend to start with the highest or the lowest possible prime number until we get to 1. So, let's say I have 136 as my main number. 136 can be broken down. First of all, it goes into 2 because it's an even number. The last digit is an even number, therefore the whole number is even. So this is an even number, it goes into 2. 2 goes into 13 6 times with a remainder of 1. That means 2 goes into 16 8 times 68 is also an even number. It goes into 2 again. 2 goes into 68 34 times. Another even. 2 goes into 34 17 times. Does 17 go into 2? I don't think so. Not even. Does it go into 3? The trick of numbers that go into 3, that are divided by 3, is when we add the digits of the number, we end up with a multiple of 3. So 17 does not go into 3 because the sum of 1 and 7 is 8. Does it go into 5? Again, 5 has a special trick. If it has a 0 or a 5 at the end, then it goes into 5. It does not have a 0, nor does it have a 5. It doesn't go into 5, it doesn't go into 7, it doesn't go into 11. Guess what? 17 is a prime number. So it goes into 17 once. And that's prime factor decomposition. I can rewrite this in the form of indices. Basically, what I can say is 136 is equal to 2. There's 1, 2, 3 2's, 2 to the power 3, because 2 to the power 3 is 2 times 2 times 2 times 17. This is the prime factor decomposition of 136. Next, we're going to talk about another sub-category of prime numbers. It is the finding or locating of the LCM, which is the least common multiple, and the HCF, which is the highest common factor. There's nothing tricky about them. If I wanted to find the LCM, it's a multiple. Multiples are greater than the number original. Let's say I start off with 2 separate numbers. And I want to find the prime factor decomposition of these 2 separate numbers. Let's say I start off with, 36 and I can say 62. All right, 36 goes into 2 14 times or 18 times, which goes into 2. 9 times, 9 does not go into 2, it goes into 3. 3 times, 3 goes into 3 once. 62 goes into 2. 31 times, and guess what? 31 is prime. 31. So the prime factor decomposition of 36 and 62, 36 is equal to 2 to the power 2 times 3 to the power 2, whereas 62 is equal to 2 times 31. If I am trying to identify the LCM looks basically for the prime factors, all prime factors with the highest degree, the highest power. So what I can see here, I have a 2 and a 2, they're both common. I have 1 with the higher power, so 2 squared will be part of the LCM times. I have a 3 squared. I don't have a 3 here. There is no 3 here. That means it's 3 to the power. It's just like saying 3 to the power 0, because that is just 1. So the highest power would be 2 again. So this is 3 to the power 2 times the third prime factor that is in both is 31. 31 has a power of 1. There's no 31 here. It's just the same as the 0 element. It's just like having 31 to the power 0, so I'll have to include 31. So this is 2 squared times 3 squared times 31 for the LCM. Now the HCF, or the highest common factor, in this case looks at only the common prime factors. And the common prime factors are 2 in this case, or is 2 only. This one has a power of 1 and this one has a power of 2. I will take the one with the lower power. So the highest common factor, my bad, sorry. I have to rewrite that. The highest common factor I meant to write, HCF, is equal to 2 to the power 1. This is the highest common factor between 36 and 62, and this is the least common multiple between 36 and 62.